So today's topic is voltage. So before moving on to details about voltage, we have to know the unit of voltage, which is volts, and it is denoted by capital V. It's the symbol of volts. And the unit of resistance is ohm, which is denoted by this symbol. Now, this is a simple circuit. So in this simple circuit, there are three components. The first one is a battery, and the second and third one, there are two resistors, and these resistors are connected together with the battery. Now, the main purpose here is to measure the voltages across each of these components. So as there are three components, so we have to use 3 voltmeters. And the rule is the voltmeters are always connected in parallel. So for this battery, this voltmeter is connected in parallel with this battery, and similarly for these two resistances, the voltmeters are connected across the two resistors. Now, this voltmeter will give me the reading for the voltage of the battery, and this voltmeter will give me the reading of voltage across resistor R1, and this voltmeter is going to give me the reading of voltage across R2. So let V1 be the voltage across R1 and let V2 be the voltage across R2. Now, when the switch is closed, that means when the circuit is closed, then the current will start to flow through the circuit. So when current starts flowing, then we are going to get the reading for the voltage. So we will observe that for the battery, the voltmeter is giving us a reading of 12 volt. And the voltmeter across R1 is giving us a reading of 8 volt, whereas the voltmeter across R2 is giving us a reading of 4 volt. Now, from these readings, we can draw some conclusions. So, if we carefully look at the circuit, then we are going to observe that the voltage V1 is 8 volt and the voltage V2 is 4 volt. This means that the voltage V2 is half of voltage V1. Now, if we look at the value of resistance, then the value of R2 is 10 and the value of R1 is 20. So here R2 is half of R1. So from this observation, we can deduce a relationship between voltage and resistance. So here when the voltage is halved, for example it is 8 and it is 4, the value of resistance is also halved from 20 to 10. So therefore we can say that the voltage drop across resistor is directly proportional to the value of the resistor. For example, if the resistance is halved, then the voltage drop is also halved. Now, so why this V is directly proportional to R? That means that some other quantity must be constant. So here in this circuit, the value of current I is constant. So when V is proportional to R, in that scenario, I will remain constant. Why here I is constant? I here is constant because the same amount of current is flowing through R1 and R2, as there is no other alternative path. The same amount of current is going to flow through R1 and R2. Therefore, the value of current remains the same. So as current is same or constant, so voltage is directly proportional to resistance. Now, we are going to move on to the second circuit diagram. So here we are seeing that there is a gap between the wires. That means the circuit is not properly connected, or there is some loose connection. So if there is some loose connection or a gap between the wires, then the circuit is said to be an open circuit. Now for open circuit, there is no current flowing through the circuit. Why? Because when there is any interruption, then the current cannot flow through that path. So as no current is flowing, therefore the value of current I here will be 0. So now we are going to look at the voltmeter readings. Previously, the voltmeter across battery showed a value of 12 volt. So here also the voltmeter across battery will give us a reading of 12 volt. But the voltmeter across resistance R1 and R2 will not be the same as previous. The voltmeter across R1, which is V1, will give us a reading of 0 volt. Similarly, V2 will also give us a reading of 0 volt. Now the question is why? The main reason here, as you can see, as I is 0, therefore V1 and V2 is also 0. So from this situation, we can predict that the voltage not only depends on the value of resistance, but also on the value of current. So therefore, as current is 0, so voltage is also 0. So this leads us to Ohm's law. So here you can see that for Ohm's law, voltage is directly proportional to current. From this equation, we get V equals to IR. That means voltage drop is equals to current times resistance. So as resistance is multiplied, therefore, when the value of I is 0, voltage drop V will also be 0. So which is the case here? As there is no current flowing, therefore I was 0. And from this equation, if we multiply 0, then we also get the V to be 0 volt.